This is a Brookside Robotics podcast. My name is Kevin Lannis. I'll be talking about the VEX Skyrise. That's the 2014-2015 VEX Robotics competition for high school teams. In our previous podcasts, we've discussed the playing field and the scoring rules. Today's topic is the actual robot. VEX is a proprietary platform used by high school robotics teams for the VEX competitions. The VEX robot must be built entirely with VEX parts, with a few exceptions that will be discussed. At Brookside, our team start out with the Classroom Competition Super Kit. This includes a basic Clawbot kit, the VEXNet system, a mechatronics add-on, and a programming add-on. The brains of the robot is a VEX Cortex microcontroller. The Cortex is programming using one of two languages, EasyC or RobotC. We use RobotC, which is a language based on the industry standard C programming language. The VEX Cortex has 10 motor ports. In other words, the maximum number of motors on any robot is 10. Motors are connected to gears, which in turn will operate the wheels, arms, pulleys, and any other moving parts on the robot. The VEX Cortex also has 8 analog and 12 digital input-output ports, which can be used connected to sensors such as rangefinders to determine the distance to an object, potentiometers for determining rotation, and shaft encoders that count how many times an axle has been turned. At the beginning of each match, the robot must be no larger than an 18 by 18 by 18 inch cube. Since this game really depends on height, most robots will then use a scissor lift, telescoping post, or some other mechanics to expand and become taller so that they can pick up the cubes and stack them on the skyrise sections and other posts. The only non-VEX parts allowed on the robot are certain screws and nuts, a small amount of clear plastic, tape for labeling and securing cables, and some nylon rope. VEX robots are powered by a 7.2 volt battery. Last year, all of our robots had one battery each. We've since learned there's an optional add-on called the Power Expander, which allows a second VEX battery to be included, giving the robot significantly more power. There is no design book or instructions. The parts come in a box with some instructions on how to operate each individual part, but the robots are really designed and assembled by the students. This concludes our podcast on the robot. Stay tuned for more VEX Robotics podcasts. Have a great day.